And there's a lot of talk about achieving a fifth-generation wireless network, that by 2020. But there's still a lot of work to do, and there are plenty of skeptics about the perceived hype around 5G wireless. Here in the TI Now studio to give us an overview of research and available technologies for 5G wireless is Kumar Balachandran. He's the principal research engineer at Ericsson Research. Also on the panel is Rakesh Towry. He's the Director of Cellular and Connectivity Systems Design at Samsung. And at the end of the desk is Dr. Jeff Reed, a professor of Electrical and Computing Engineering and Director of Wireless at Virginia Tech. And gentlemen, welcome to the program. Well, let's get started here. Let's talk about something that I heard that I found was interesting in the workshop. Someone mentioned that there's no universally accepted definition of 5G, a 5G network right now. Without asking you what your definition of 5G is, and Kumar, I'll start with you. And by the way, I want to preface this question by saying that you're also not only speaking from the perspective of Ericsson, you're also speaking from the perspective of METIS, which is the EU standards organization. Is that correct?
It is an EU research program, EU-sponsored research program, yes.
Okay, based on that perspective, and of course Ericsson as well, what would you say constitutes the, I guess, primary characteristics of a 5G network?
Well, it's interesting to sort of step back and try to look at what are the drivers for a 5G network. And primarily we see two main drivers for this. One is the huge increase in traffic that you're going to see. Some say that it's going to be a 1,000-fold increase in traffic by the year 2020. And then there's an explosion in the number of connected devices that the network is going to see, not just from devices that have that enable connectivity between human beings, but also devices, machine devices, and sensors, and devices in cars, and so on. But to get back to 5G, essentially what the network will have to do is to be able to handle this level of data volume, and also be able to handle the increase in the number of connected devices. In addition, of course, there are certain situations where you would want much higher data rates than are possible in today's networks, say 10 to 100 times of data rates. And perhaps in certain scenarios, you'll have the need to have much greater energy efficiency, greater increase in battery life, and so on.
So Kumar, in addition to what you have just said, in my opinion, also another requirement for 5G or a characteristic or a defining attribute for 5G would also be providing a uniform quality of experience to the user, as opposed to just having very high data rates at some point, but very low data rates at the edge of the cell. So one of the things that Samsung is actually evangelizing in the context of 5G is a uniform QoE, a gigabit per second anywhere type of experience for the user. We think that would be essential for having the immersive experience that many of the applications coming down the line would actually require.
Well, actually, I see three things composing the characteristics of these 5G networks. First is the ability to be able to use a variety of bands. You can think of this as, in technical terms, as carrier aggregation on steroids. High-frequency bands, millimeter wave bands, unlicensed spectrum, licensed spectrum, bringing it all together to support a specific application. And it might even be that we have a variety of networks that are working together to support an application. And this unification of these heterogeneous networks is the second characteristic. And then third, for 5G systems, we're going to see much more intelligence in the network, being able to perform deployment and maintenance automatically. And this is going to be essential in order to achieve the scalability that Kumar mentioned earlier.
And I might want to add a couple of other things as well. So in addition to the points that have been made, lowering the cost per gigabyte while actually maintaining also lower energy, so lowering the bit per joule that you can get, lowering the joule per bit that you actually need to spend. These are also going to be important factors. And last but not the least, we have to start thinking of providing access to also the next billion. I mean, we have seen that mobile technologies have touched 5 to 6 billion people. So we need to also prepare for touching the next billion people.
Rakesh, I'm glad you brought up the cost per delivery issue. Of course, we're going to get to that a little bit later. I'm glad you brought it up. Kumar, again, I want to start with you. I want to talk about 5G wireless not only being about increasing connectivity speeds, but also enhancing and elevating evolutionary technologies and also revolutionary technologies. A few of those are cognitive radio, multi-technology carrier aggregation. Again, these were talked about in the 5G workshop. Steerable millimeter wave beams, which I think Rakesh is going to allude to in just a moment. But what is Ericsson and what is Metis focusing on right now?
So all these are good topics. Metis actually is focusing on a lot on spectrum sharing technologies. And spectrum management research is a very important aspect of the exploratory work that's happening. In addition to that, of course, we have the problems of handling multi-node mesh connectivity in networks, being able to handle different layers of networks in heterogeneous environments, as well as being able to handle new ways of communicating, such as cooperative communication. Very large MIMO is a very important aspect of what Metis is involved in. And there are, of course, various scenarios under consideration, ultra-dense networks, which handle virtual reality type of environments or urban dense deployments. In terms of device-to-device communications, moving networks which involve radios that are in vehicles that are communicating with the infrastructure. Reliability is a very important aspect of what.
Very interesting points indeed. Perhaps what I'd like to add to the list, and during the workshop I alluded to 7 or 8 different technologies that we are looking at. Millimeter wave in terms of spectrum, of course, in terms of getting very high data rates, but we also need to look at this uniform gigabit experience. But what I'd like to point out is this high gain phase array antennas with beam steering capabilities in order to actually best able to utilize some of these very high speed technologies to give users high data rates. And with this will come other technologies that we will need to provide a uniform data rate, like advanced small cells and D2D technologies that I was referring to earlier. Perhaps,
well, I agree with both of you. Those are very important aspects. I would also add cognitive radio is going to play a very important role, adding intelligence to the network to be able to manage interference in the environment. But beyond that, being able to do, in general, radio resource management across multiple networks, multiple providers, across multiple bands. I think that's going to be very key to achieving the scalability that we're going to need to get this 1000x improvement in capacity over today.
Of course, spectrum is very important to, I guess, the launch of a 5G wireless network by 2020 and beyond. This was talked about quite a bit in the workshop, as you know. Rakesh, I'm going to start with you. If we don't get the spectrum that we need in order to, I guess, support the infrastructure for a 5G network, we have to make spectrum that we have currently more efficient. How do we do that?
So we have world-leading expert on spectrum sharing, so I'm going to leave the spectrum sharing to Professor Reed here. But I'm going to talk about technologies that could be useful for small cell. And I think, again, just as we had OFDM MIMO define the 4G technologies, we think that beamforming would be a very defining technology for 5G, whether it's applied to the cellular bands, as people are talking about full dimension MIMO, people are talking about massive MIMO, but as someone commented in the workshop, truly massive MIMO is probably only possible at higher frequencies, but that's definitely going to be one thing. Then the spatial reuse, which will be enabled by beamforming technologies, is actually going to lead to better spectral efficiency, so that's definitely one thing. And we also need to think of beamforming in the form of actually reducing the energy per bit, in that you're folding energy into beams and you're causing lesser interference to the others. So that's how it will also help. And in terms of overall efficiency, right, we think that the cost of acquiring spectrum will go down as you move to higher frequencies. So you're getting more megahertz in some sense. So as the cost of buying the spectrum goes down, the operators are likely to pass that on to the consumers, thereby bringing the cost down, which is also overarching point in terms of efficiency.
Yes, I mean, if I were to add to that, of course, what we need to look at is technologies like MIMO or beamforming are, of course, available in the toolkit that device manufacturers and operators have to when they field their systems. But we need to, in terms of spectral efficiency, we need to differentiate between spectral efficiency and spectrum utilization. A lot of the regulatory work that's going on is geared towards improving utilization of spectrum across diverse use cases. For instance, if you look at the way the US government handles spectrum utilization, the government is quite adept at sharing spectrum between various branches of government. So that could be a piece of spectrum that's used by the Navy, that's also used by NASA elsewhere in the same region. But when wireless operators deploy spectrum, of course, they look at spectrum efficiency within the context of their wireless holdings. So there are, of course, tools available on either side to deal with the problems that you face with regard to interference management and with regard to intelligence in dealing with spectral resources.
That's a good point.
Well, I think that, as I mentioned earlier, I think spectrum sharing is going to play a very important role in that. But there's still a number of outstanding issues before spectrum sharing can become a reality of how we do this global optimization across the spectrum. There are some significant security and privacy concerns that have yet to be addressed. And finally, how do we regulate this, particularly when we have frequency agile devices that are software defined and they're in every home? You could see that there's a lot of potential for abuse with these devices.
Rakesh, I want to move on to the challenges that we're facing moving towards this 5G wireless network. I want to start with urban testing, urban test sites. Tell me more about that. It's interesting.
Okay, thanks for asking that question. And actually, for millimeter wave part in particular, so going back, as we use the cellular bands, we have now a lot of experience. We understand how the channel behaves. We understand the propagation physics quite well. But as we move to higher frequencies, and there's a lot of talk on millimeter waves, so in that sense, of course, it's the right time to ask, what has been the experience in terms of urban test sites? So we have conducted experiments in Manhattan, in Brooklyn. Actually, Professor Ted Rappaport from NYU has done that. And there are a lot of results now, and I presented some of the path loss exponent that we actually obtained, which were not that much different from the cellular path loss exponents that you actually get. Of course, these were obtained by beamforming, so that is an important point to consider. Some of the things that people think with millimeter waves are also whether or not it's capable for or suitable for non-line of sight communication. But again, as we alluded to in the workshop, with beam steering and actually reflecting off other buildings and things which would be very characteristic of urban deployments, that we can actually collect enough energy. So what we are noticing, there's a long way to go, first of all. What we are noticing is that beam steering, beam tracking, that's actually doable. We have also done indoor to outdoor tests, not conclusive, not very exhaustive at this stage. A lot of work needs to be done. We've also looked at things for going through tinted glasses, where again, we do not observe that much more degradation as compared to cellular bands. Penetrating through walls, indeed, is an issue. However, it's like shouting louder. So if we can get more gain by high gain antennas, that's again something that could be overcome. There are challenges. But I think that these are not challenges that cannot be overcome. Samsung, for example, our current prototype is a matchbox size 8 by 8, so 64 antenna array, where we have actually shown beam steering and actually communication of up to 210 meters roughly in non-line of sight. So there are challenges, but we are working towards alleviating those challenges.
Did you want to comment?
Yeah, I think Metis's view and Ericsson's as well is a bit more holistic with regard to what 5G technology really is, because we don't like to associate the evolution of the network with a particular frequency band or with a particular air interface as such. What we believe is that there are going to be revolutionary as well as evolutionary approaches to dealing with the future, and that it's certainly possible that millimeter waves or even higher frequency bands than the ones we operate at today may be warranted at some point in the future. But at the same time, one shouldn't forget that existing networks are also going to evolve. You really have to look at the use cases and the scenarios that you want to address to be able to.
I want to get back on this just a little bit. Actually, if I'm painting that our view of 5G is only millimeter wave, that's not correct at all, actually. We totally agree with you that 5G is much more than millimeter wave, because the question was related to propagation conditions and in urban test sites, since we already have a lot of data for cellular bands. That is why I was actually focusing on. But once again, we truly also believe that 5G, millimeter wave would be one aspect. Even as you saw a presentation in the workshop, we think there would be several more technologies, including the ones that are existing, that will evolve and lead to higher data rates as well as enhancements. Thanks for bringing that up.
Kumar, when we talk about 5G wireless, and this workshop today was no exception, for some reason, or for a number of reasons I would imagine, there's tangential discussions and conversations about virtual networking. And of course, I'm talking about software-defined networking, network function virtualization. What's the relationship between SDN and 5G wireless?
So the Metis program also has an architectural dimension to it. And there are, of course, changes happening in the industry today pertaining to software-defined networking and also network function virtualization. What we believe is that SDN and NFV will actually serve to increase the ease with which services can be characterized as well as provisioned in the network. The Metis architecture is, of course, expected to use concepts like that. If you look at the Metis objectives, the architecture is expected to address new trends based on software-defined protocol stacks for end-to-end flow delivery, and then software-defined content delivery, on-demand creation of virtual network slices, dealing with decentralized or centralized or hybrid radio access network architectures, named data networking, cloud computing, and so on.
Want to talk about, Rakesh, did you want to comment? No? Move on? Okay.
It's just informative.
I want to go right into research from the perspective of industry, of course, and academia, of course, as well. We have a representative from there. Government, I know that was a discussion that was had in the workshop, and we can post those comments after the panel in several forms. Let's stick to academia just for now. Dr. Reed, I want to talk to you about what's happening right now at Virginia Tech as far as 5G research. I'm aware that you have a keen focus on 5G wireless.
That's right. And we have a number of sponsors for this work. DARPA, National Science Foundation. We have been looking at new networking technologies for machine-to-machine communications. We've been looking at how you do carrier aggregation and how you can share spectrum between communications and radar. And that's going to be a very important area, because if you look at the way spectrum is allocated, much of it today is allocated to radar systems. As what Willie Sutton say, why do you rob banks? Well, that's where the money is. And certainly that's where the spectrum is. And so if we can show that we can simultaneously support radar and communications, we're going to make available a lot more spectrum.
Rakesh, what's happening on the R&D for 5G from industry?
So actually, thanks for bringing that up. There are several initiatives that are going on in different countries. For example, in the UK, a 5G Innovation Center was created this October in Surrey University. In Korea, the activity is under the umbrella of the so-called 5G Forum, which is actually established by the Korean government, Ministry of Science, ICT, and Future Planning. And likewise, in China, there's IMT 2020, and there's a government national project called 863. And also at ITUR, where typically a lot of the next G activities are actually kicked off, it is now discussing what is called Future IMT Vision Beyond 2020. And it has also started a feasibility study for higher frequency above 6 gigahertz. So these studies are actually scheduled to finalize in 2015. So that's roughly, compared to the United States in some sense, in different countries, things have picked up. And here in the United States, thanks to the activities organized by yourself and several different things. And there's a lot of offline discussion going on. There are a lot of discussions with FCC as well. So a lot is brewing.
Kumar, Rakesh just mentioned some activity going on overseas as far as moving towards a 5G network. I'm glad you're here. I'm glad we can talk from the, did you want to?
Yeah, well, I mean, just to add to that point, of course, I am partly representing Metis over here. And to give a few words about what Metis is all about, it's basically a 2.5-year exploratory research program. It involves participants from the wireless industry, both operators and vendors, as well as there's BMW, and there are 13 academic institutions. And the basic objective of Metis is to do research that will pave the way to 5G.
Why is it, is the assumption accurate that organizations like Metis, other organizations overseas, are a little bit ahead of the curve as far as moving towards a 5G network? And if that's so, why is that?
I don't know about whether organizations like Metis are ahead of the curve. I would say that the European Union has a history of funding large collaborative research projects. This has happened ever since the success of GSM. For instance, the ACTS Frames program led to UMTS, and then there was the Winner project that preceded the development of LTE. And in a similar fashion, of course, the 7th Framework Program has adopted Metis as one of the programs that will look at future generation wireless communication.
Dr. Reed, I'll ask you this question. Just don't get angry with me. Is academia overseas and other parts of the world ahead of the curve compared or contrast to academia here as far as working towards a rollout of 5G wireless?
I would say that Europe in particular is ahead of the US in this area, and there's two reasons for that. First is the money. It's a matter of national priorities. And in Europe, wireless is clearly an economic engine for them, and they understand it, and they're willing to invest in it. Second, in Europe, they tend to have much more collaboration between universities and companies. It's a different philosophy than it is in the US, and they tend to do research which will advance the next generation, a very focused effort. So for companies, they see that this is going to impact their bottom line, and they're more willing to invest in research. In the US, tends to not value research. Government organizations tend not to value research that have a direct impact on standards. I'm sorry to say, but that is the way it is.
Any comments on that?
Very interesting to hear that view.
Dr. Reed, I want to start with you about, of course.
If
go ahead,
I may,
please.
if I may actually jump in over here, I mean, we shouldn't interpret this as saying that the US is behind the curve. I mean, there is a fair amount of research that's going on in the US on wireless. And for instance, many of our competitors and we ourselves do fund some research in the US. And we do some of the industrial research in-house within the US as well. That being said, I sort of agree with you that perhaps there isn't as much of a collaborative focus, and perhaps the country would benefit from some additional focus around the label of a 5G effort.
Yeah, I agree with you, and some of my colleagues believe that if research involves a standard, it's not research, and they're just ignorant of the standards process, the fact that standards tend to be wish lists of technology. There's plenty of research, good research that can be done that will help support the standardization process.
We're happy to have a representative from a standards body, of course, a representative from academia, and of course, not last but not least, a representative from industry. We appreciate all three of you being with us. Thank you for being present for the 5G workshop. We thought it was a success, and we hope you'll agree.
Yes, definitely. It was a very good opportunity to hear other people's views and get stimulated on several of the ideas that, other people raised. It was a very well organized workshop. Thank you very much.
We appreciate it. Rakesh, Dr. Reed, and Kumar, thanks once again.
Thank you.
Thank you.
And thank you for watching this segment of TIA Now. For the on-demand version of this show, please log on to tianow.org. And as always, you can follow us on Twitter at #TIA_now. So long.